Hello, everyone. A couple of people have been in contact with me about question 5 on homework sheet 61, which is the 5th homework. So I thought I could maybe give an example a bit like it in case it's of use to anybody. I'll just have a look through it. So here's an example that's similar to the examples on question 5 on sheet 61, which is about the concept and meaning of convergence for a sequence. And so in this problem, we're told that the sequence an is defined this way. It's the term an is the maximum of the numbers 0 at minus 1 to the n over 2n. So this notation just means that the term an is the maximum of these two numbers. And since the two numbers, in particular the second one, depend on n, the maximum is sometimes 0 and sometimes it's minus 1 to the n over 2n, depending on what n is. So we are provided with the information that the sequence converges to 0. What that means, of course, is that no matter how narrow a band we choose around 0, we'll be able to find a number capital N with the property that all terms of the sequence from after that one, indexed by capital N, should be within our narrow band around 0, which means that it's absolute, that the absolute value of all of those terms should be at most equal to the radius of the narrow band, no matter how small we choose our narrow band to be. Okay, so what this task or this question is about really is just sort of precisely interpreting that definition. And what we're asked for in this particular version is, if epsilon is 1 over 800, what is the least n with the property that the absolute value of the term an of the sequence is less than 1 over 800, whenever little n here is greater than capital N. Okay, so the concept of convergence tells us that, we can choose some n for which all the ans after that point are within 1 over 800 of 0, so their absolute value is less than 1 over 800. Our question is, what's the smallest possible option for such an n? Because that's what we have to think about. And I guess a thing to note when you're looking at different versions of this problem, which appear on different people's sheets, is that we have to be really careful about exactly what the terms are, how they alternate between what values, and also whether your question asks about all n greater or equal to capital N or all n greater than n, because all of these things need to be considered. So for this particular problem, I suppose I would suggest that the first step is to just figure out what the terms of the sequence are doing. So you don't have to write anything because it's obviously an online homework. But what I would be doing if I was thinking about answering this question would be, first of all, figure out, what are the terms of the sequence? Do we believe that it's converging to 0? We're told that the sequence starts with n equals 1 and continues through all the natural numbers from that point onwards. So when n is 1, we have the maximum of the elements 0 and minus 1 to the 1 over 2 times 1. So the maximum of those two numbers is 0. 0 is the greater of the two, the other one's negative. So A1 is the maximum of those two numbers, which is 0. A2 is the maximum of 0. And when n is 2, minus 1 to the n is 1. It's an even power of minus 1. 2 times 2 is 4. So our numbers in that case are 0, 1 quarter. A2 is the maximum of those two, which is 1 quarter. N equals 3. A3 is the maximum of 0, and this time it's minus 1 over 6, but certainly because n is odd, minus 1 to the n is negative, and the second contribution there is going to be negative, so the maximum of the two of them is going to be 0. So an is going to be 0 whenever n is odd, because in those cases the other sort of candidate is negative. It's an odd power of minus 1. And when n is 3, n is 4, A4 is going to be positive this time, because it's the maximum of 0 and something that's positive, and that positive thing is 1 over 2 times 4. So that's 1/8. And in general, that we can say that an is 0 when n is odd, because in that case it's the maximum of 0 and something negative, so it's 0. An is positive when n is even, and what it's equal to when n is even is minus 1 to the even value of n, which is 1 over 2 times n. So I guess with that information, at least if we couldn't see it before, we can agree that the sequence is converging to 0, because certainly when you look at the even index terms 1 over 2n, as n increases to infinity, 1 over 2n is certainly going to 0, and the odd terms, the odd index terms are already 0. So yes, the terms of the sequence alternate between 0 and 1 over even natural numbers. Okay, fine. That's how they look. So the sequence goes, if you prefer to have a more explicit version, it goes 0, 1/4, 0, 1/8, 0, 1/12, and so on. 0, 1 over 16. The 1/10 term and the 1 over 14 term would occur when n equals 5 or n equals 7, but in those cases the value of the term is 0. That's how the sequence goes. So on. So we can say that, yeah, so an is 0 when n is odd and 1 over 2n when n is even. So in fact, multiples of 4, 2 times an even number, will appear as denominators in the non-zero terms of the sequence. Okay, so we have to ask ourselves, that's okay. I mean, that's fairly, we can certainly see what the pattern of terms in the sequence is. Now we must go back and see, well, what are we supposed to say? What are we supposed to answer? So what we are supposed to ask ourselves is, basically, what capital N do we have to choose in order to ensure that whenever we go beyond term A, capital N, and look at all further terms after that, they all have the property that their absolute value is less than 1 over 800. Right, so we have to ask ourselves, when are we going to get something like 1 over 800? When are we going to be in the right ballpark? And then we can figure out the details after that. So our question is, when does the value of AN kind of reach around 1 over 800? And that's the next question. And then I think after that, we can figure out precisely what is the question we're asked and what is the exact answer that we should give. So that's sort of the first thing that I would ask myself if I was tackling this question. Second thing I'd ask myself would be, well, when do the terms get nearer to 1 over 800 in absolute value? So again, luckily, that's not too hard to answer because of the form of the terms of the sequence. So we can certainly say that, an is 1 over 2n when n is even. So when n is 400, A400 is 1 over 2 times 400, so it's 1 over 800. A399 is 0, because 399 is odd. A398 is positive, and it's 1 over 2 times 398, which is 796. So that's greater than 1 over 800. So that's kind of not of interest. And the ones before that, if they're positive, are going to be greater than 1 over 800 as well. So this is kind of the crucial point. Well, where those two red stars are, that's, the 399 term is 0. The 400 term is 1 over 800. Now we better look and see exactly what are we actually asked for. We're asked for what is the least n, capital N, for which absolute value of an is less than epsilon for all n greater than n. Okay, so the answer is not 399 or 398 because A400 is still not less than epsilon in absolute value. It's equal to epsilon in absolute value. So this 1 over 800 is equal to epsilon. Okay. After that, A401 is 0 because 401 is odd. A402 is 1 over 804, which is definitely less than epsilon in absolute value and in any other. Okay, and from then on, they're either going to be 0 or they're going to be 1 over something greater than 800. So all terms from then on, all terms from this point on are certainly going to be less than 1 over 800. They're either 0 or they're 1 over some even natural number that's greater than 804. So basically, if we're asked what is the least n with the property that an, the term an is less than, strictly less than, so if you've got a less than or equal there, you need to think slightly differently about it, whenever little n is greater than n. So this is strictly greater than. So it's something in this ballpark around 399, 400. If little n is greater than 400, then it could be 401, 402, and so on. From that point onwards, all the terms from 401, 402 onwards are strictly less than 1 over 800 in absolute value. So we can say, but there's no lesser n that would do that trick, because if we tried n equals 399, which looks plausible as well, well, there's one term after that which is actually equal to epsilon and not strictly less than epsilon. So basically the last term that's not strictly less than epsilon is A400. So if we take n, capital N, to be 400, then for every index greater than 400, that's 401, 402, and so on, all of these terms are less than 1 over 800 strictly. So the answer here would be n would be equal to 400. But just be a bit careful when you're answering your version of this question. I mean, the kind of thought processes that we need are all here, I think. But, you know, if the question here was for all n greater or equal to capital N, then the answer would be 401, not 400, because it wouldn't be satisfied for 400. If the question here was an in absolute value less than or equal to epsilon, then that would be satisfied by A400. It would also be satisfied by A399. So the answer in that case would be A398. So I don't think any versions of this question are sort of easier or harder than any other versions, but you do have to be attentive to the kind of precise way that the question is formulated. And so basically, I mean, all the examples are sort of broadly similar to this one. First step, figure out what the terms of the sequence are. Second step, figure out when they're close to the epsilon that you're interested in, and then just figure out exactly, in terms of how the question is posed, exactly what the right n is for your version. So I suppose it's an exercise in kind of thinking in really sort of careful attention to exactly the definition of convergence for a sequence. So I hope that is of some help. I'll leave it there and say thanks for watching. Thanks, everybody.